Too expensive. All right. Sorry, guys, for the all the troubles with the tech stuff. Sometimes whiteboards are just the way to go. All right, here we go. We talked about the first property and the second property before. So we revised f of g means function. The g function is put into f of x, and that's what I'm saying there. So f of g means that I'm substituting g of x into the function f, hence function within a function. Yeah. We said that the first property was that the range of your first function, because you're putting x into this, and that's the y value needs to fit into the domain of f for it to exist. Okay, so that's the first thing that you need. And then I showed you the logic to it. Let's have a look at this. Now let's look at this problem, and we're going to try to use exercise 1E, what the skill has to be, right? If I look at this, we want to break, the first skill is to break out what is the first function, what's the second function. Okay, now if you think about it, if I put in x equals 1 into the machine, which one am I subbing in first? Can you see two functions in square root of x squared minus 16? Which two functions do you already see? Which two do I have?
X squared minus 16.
I got x squared minus 16, which is a quadratic. And what else do I have?
X squared.
I've got a root x problem, square root x. Okay, so all the functions you have a square root, you have a quadratic. Now in this case here, I can break it apart. This is the first function I'm dealing with. It's x squared minus 16. Whatever that answer is, I'm going to square root afterwards. So this is my quadratic, x squared minus 16. That's the first machine, okay? My second machine is the square root of whatever the answer is. So if you really think about it, I'm just saying that g of x is equal to x squared minus 16. I'm saying that f of x is equal to root of x. So when I say f of g of x, that clearly makes sense that I'm going to substitute x squared minus 16, which is here. That's my x squared minus 16. I'm substituting in here. I'm replacing the x, yeah? And that's how you get, I'm going to write it in red again, root of x squared minus 16. Okay, individually we know what the graphs look like. We know what x squared minus 16 looks like. It's a quadratic. We know what square root of x looks like. But to combine them, what does it look like now? That's what you need to be able to figure out. And hence, if you can figure it out, you know the range, you know the domain, right? Now, in order to check, we need to first check, does this machine even work to begin with? Does this really work? If I just chose any number, would it at any point not work? If I put a number in, does it spit out and it goes into this machine, and does it spit out another number? Because if it doesn't work, that's a problem, it's not defined. And sometimes it won't work. Those are the questions you're going to get. They're going to say, is it defined? So is f of g defined, or is g of f defined? Your job is to figure out, does it work or doesn't it? And when it doesn't work, then the next question after that they'll say is, well, fix it. Make it work. And that's what I want to teach you today. Okay? And you're going to practice that with the sheets. You're going to practice in the exercise. I want to do the videos over the weekend so that you understand that concept, what you can change. Okay? So let's look at the machine here. If I put a 1 into the machine, let's see if it works. If I chuck in a 1, x squared, which is the x value, I'm going to change x to 1 now. Now then I'll have 1 squared minus 16. 1 squared minus 16, what does that equal to?
Negative 15.
Negative 15, because 1 squared is 1. 1 take away 16 is negative 15. So that means the first machine spits out a negative 15. And I'm going to put the negative 15 into my second function. Okay, it's like saying if I put a 1 here, 1 squared, which is 1, 1 minus 16 is negative 15, and then I square root that. That's what f of g is. So if I square root negative 15, what happens there? It's undefined. I can't do that. I can't square root a negative number. So right now, I can already say x equals 1 is a problem. Doesn't work. That machine doesn't work. But surely there's got to be other numbers that it won't work, and there's other numbers that it does work. Now what you don't want to do is to sit there and keep trial and error, because that's not what methods is all about. Methods is about identifying, well, what is the range of numbers that you can work with, and what numbers can't you work with. Okay, and so here, whilst we understand what doesn't work, let's find something else that does work. So if I chose 1 doesn't work, do you think negative 1 would work? No, negative 1 won't work as well, because when you square it, it's still smaller than 16. 1 minus 16 is always going to be a negative number. So what's the minimum? 4. 4 squared gives you 16. 16 minus 16 is 0. So I need to choose any number other negative 4 and beyond. True? Now that was from a logical standpoint, but we don't want to do that because I can give you a graph where it might not be logical. then you can't just sit there and go, oh yeah, square root of this, that has to be between there and there, right? I already know the answer is 4 onwards and -4 onwards in the negative region. Anywhere in between is not going to work, right? That's what I know just by looking at the equation. But I want to teach you, how do you see that? How do you figure that out? And I'll show you here. Your job is to sketch each one individually, okay, and write out the domain and range. So here we go. We're going to do 2 techniques here. I'm going to do it in blue. First, we're going to write out our range and domain. So we got our domain, got our range. This is G, this is F. Okay, domain of G. If I just gave you an x squared minus 16, which I'll draw on the side here, G, x squared minus 16, what does that look like again? Anyone know? X squared minus 16, what does that look like? It's quadratic, so we know, is it a positive quadratic or is it a negative quadratic? Positive, so it's a smiley face, right? Then now you're going to use what you learnt last year about translations. You've got x squared, what does the minus 16 do? Good. Minus 16 drops the graph down and shifts it down. It's a translation down along the y unit. So what it should look like is it should go down by 16, or the turning point, as you said, 0, -16. This is what my graph looks like. From what you learned from quadratics, how do I find x-intercepts again? Back to year 9 and 10. How do you find x-intercepts?
Oh, you make it into brackets.
Good. You make this into brackets, and remember to find out these x-intercepts, let y equal to 0. So if I solve that, if I let this equal to 0, you've got 0 equals to x squared minus 16. Now you can factorize it into using difference of perfect squares. It's x minus 4, x plus 4. That's why you were doing that back in year 9, year 10, year 11. Yeah? It's equal to 0. This is what you were doing last year. First half of last year. X minus 4 times x plus 4, and you know that x then has to equal to? Plus 4, -4. And what does that really mean? You just found out the x-intercepts here, right? You just found this is when x is 4, -4, sorry, then y 0, and when x is 4, y is also 0. Great. I've drawn my graph. Now, if I asked you the domain and range to fill out the table over there, what's my domain? All real values. This is exercise 1B, yeah? 1B, so domain of G, What is my range? Oh, yes, Ivana?
I was just asking that first.
Yeah, if you just keep going. Do you mean like word solutions for exercises?
Yeah, just like for the one chapter.
Yep, it's on the Schoology.
Oh, okay.
On Schoology, under the textbook, there's a folder that says work solutions there. Yeah? So, next part. I know that R is my domain for G. What is my range for G looking at this graph here? What's the range? -16, which is the lowest y value, all the way up to infinity. So I'm going to write it down. Range for G is -16 all the way to positive infinity. Right? Now let's do F. So I've drawn the graph for G. Let's draw the graph of F. So I'm going to draw the graph of F here. This is F, and F is just the square root of X. Square root of X, what does it look like again? Anyone remember? Yeah, just looks like that. Okay, just the top half. It's a function. There we go. If this is my graph, what is the domain? What is the range? Good. R plus including? 0. Just make sure you put that. Or you can just say 0 to infinity, 0 to infinity. Great. Now, what was the first property again? The property said that the range of the first function needs to fit the domain of the second. So, what's my first function? So an x squared minus 16. So that's my G. So the range, which is -16 to infinity, this needs to fit whatever this restriction is. This one says I can't have any negative numbers. That's the domain. Domain says only 0. I can only take numbers between 0 all the way up to infinity, but positive. That's what this is saying. So the second function says I can only take, and we're going to highlight it so you can see. This is what they're saying. They're saying, I will only take this. What can you give me? The person says, I can only give you this. That's what they're saying. They're saying, I can give you this. This person's saying, I only take this. What's the issue already? Where do they overlap and where don't they overlap?
0. You can't take 6 from negative
Yeah.
numbers.
See, this is all the way negative 16, all the way to positive infinity, whilst this is only cutting off at 0 to infinity. This is a problem. This is a problem because we can't take anything from negative 16 up to 0. That's what we were saying. We were saying the y values, if I highlight it for you, this is the region we don't want. That is why when I said if x equals 1, can it work? See, I don't need to guess it. I can visualize it. I can say x equals 1 here. If I sub it in, it's going to be a negative number. If I take that negative number and chuck it over here, it's not going to work. Because this number here says, I only want positive values. That's what they're saying. They're saying, I only want this. Give me positive numbers. Whilst the only numbers I'm giving are all the y values. That's why I'm looking at the quadratic, and I told you before on a logical basis, it made sense to us from 4 onwards, or negative 4 onwards. And that's what I'm showing. Negative 4 onwards will all work, and all the 4 onwards here work because all the y values here are positive. All the y values here are positive as well. Whereas down here, this is all negative. When will I get a negative number? It's when I choose any of these x values. Negative 1, 1, 2, negative 2, 2, 0, all of that's not going to work. And you can test it if you want. You can trial and error and chuck it in 0, and it's not going to work. But we don't want to trial and error. See, now I can look at these two graphs. I can tell you exactly what will work and what isn't. So now I know the problem. See, if I draw a number line just to illustrate what the issue is, this is the issue. I'm going to draw it in, oh, whoops. I'm going to draw it in green. See, if I drew a number line, the range of g, which is negative 16, let's say negative 16 is here, it's from here all the way to infinity. Whereas the domain says I will take from 0 to infinity. That's why that's a problem. See, the range, that's my range of g. This is my domain. So the domain says, cool, this is what I take. This guy's like, yeah, that's cool, this is what I give. I'm like, yeah, but I don't take this. So if I don't take that, we have to tell the green person to go, stop what you're giving too much. I only need 0 onwards. So this is your skill now. So your skill is to, how do I fix my range? Because I know the range currently is negative 16 to infinity. How do I fix this person's problem? Because this person says, I only do negative 16 to infinity, which is what this graph is. But I don't want this yellow region that I'm giving. What do you have to do? There's only one thing you can do. How do you fix a range? Change the domain. And that's what we were talking about last lesson. We said the only way is change what you're putting in. See, if I don't want it not to work, don't put a 1 in. Don't put a 2 in. So tell me what not to put in. That's the domain. Whatever you're putting into the machine is what you're telling them that you're going to give. So if you don't want any numbers between negative 4 to 4, just tell them. Just say, hey, it's all good. Just change the first machine. Just tell them what you don't want to take. Just tell them that what you don't put in any numbers between negative 4 and 4. And how do you say that? You would say the domain of G, instead of it being R, that's the issue. See, you start off by saying, yeah, put all numbers in. Any number's fine. And then suddenly you're like, no, actually not all numbers work. Okay, so that R is the issue. Change that R, you get a different Y value. So what's your R? Instead of saying the domain is R, you are now going to say, I want every number except anywhere between negative 4 and 4. That's what you're going to say. And that's where you learn exercise 1A. 1A was notations. Describe that. You've got a lot of ways to describe it. I'll show you so many ways. Here we go. We can say domain of G. You can say negative infinity up until 4. Negative 4, inclusive, union, 4 to infinity. See, if you say that, that will make it work. See, if I said just take negative infinity to 4 and 4 to infinity, my range is going to be 0 to infinity. It works. That's one way of saying it. What's another way of saying it? You could say, take any number you want except for, see, backslash, or I'll backslap you, backslash, except for, don't take negative 4 to 4. That works too. But you find your own language. You just need to tell them what machine you don't want to put in, what you don't want to put into the machine, so that it doesn't spit out a problem. That's your goal. That's essentially what you're trying to do. Okay, so the skill of 1E is that. Change the domain. Yes?
With the thing that you said, domain of G equals domain of G.
Domain of...
The second one, domain of G.
Yeah, the range of G.
No, the domain of G.
Domain of G.
you said equals the domain of f of g.
Yeah.
But what would it be there?
Yeah, so this one's a problem. You see, you can't have, remember I told you there were two parts here?
Yeah.
This one doesn't exist already. Because this one, the range doesn't fit. That was the problem, the range doesn't fit. So you don't even have condition 1 down. Once condition 1 is down, then you have condition 2 where the domain of G is the domain of F.
So it's the range of the first function
Yep.
has to equal the domain of the second function.
Has to fit. It doesn't have to equal. It has to fit in the second one. Once that fits,
So if they were reversed, it would be okay. So if the domain of F
yes, right.
was
Yes. Yes. So if you switched it around and you did sub the square root of x in here, it works because if you put a square root here, the squared and square root cancels out. And you end up with just x minus 16, which is a linear equation. Everything works. There's no drama. You can put any x values you want. In this particular case, when you put a square root the other way around, there's a restriction. Yeah?
Then what's the domain range for that?
Very good. So, just to tie everything up now. So I've talked about, listening, I've talked about f of g. I've shown you what the issue was. We just fixed the issue by doing this. We said change the domain of g to this now. So I said, that one's a problem. That's why this doesn't work. This one doesn't fit that. So condition 1 is not met. Therefore, you can't even go to condition 2. Condition 1 needs to be met first. So once I change this, the domain of g, to this now, the range will be different. So if I change the domain to negative infinity to 4, negative 4, and then 4 to infinity, I'm just saying, take all this. Ignore the middle. So the y values would now be all this and all that, which is 0 to infinity. So that changes the range. The new range now, the new range of G, which I'll do in green, the new range of G is equal to, and that works. See what I'm doing there? So that was the issue. I've changed that. That gives me a new range. That range now fits F, or the domain of F. Therefore, condition 1's met. Now you can say the domain of your f of g is domain of g. What's domain of g? The new one. New one I made. That new one is what I'm fixing, and that's your skill. That's what you're trying to do in 1E. You're trying to master what you need to fix to make it work. Okay, so the first skill is to identify, breaking it up into 2 sections. So if you look at my worksheet, it's asking you what's f of g, what's g of f. Okay, the second skill is then define, does condition 1 meet? And if it doesn't, how do I fix it? That's essentially what they're saying. Okay? Yep. That should be a closed bracket. This one or that one? This one. That one.
I was gonna say, isn't it the second one supposed to be a bracket because you're saying except
Oh,
minus?
sorry.
Yeah, that's what I was saying before, but I just let it go.
Which one? This one or that one?
That one, the second one.
This one?
Yeah.
Should it be a close or open, is it?
Yeah. it should
So I'm
be
like saying excluding.
Yeah, it's saying including.
Oh, you do want to include 4?
Yeah.
Oh, what am I thinking? Sorry, I was actually in my head was remove the negative 4. No, you're right. Actually, this is a good point to bring up. The second one that I wrote, it was because of my intention was wrong, and so that's why the notation's wrong here. But if you read it carefully, this happens in your multiple choice, so it's worthwhile sort of noting the notation here. What I said here was all real numbers, except means I'm not going to include, right? And what am I saying here? I'm saying don't include the number 4, don't include the number negative 4, and anywhere in between it. But reality-wise is, I did want to include it. I did want to have a negative 4, and I did want a 4. So by saying don't include this negative 4, that's wrong. What I meant to say is don't include everything between negative 4, and this is like a double negative. It's like a double negative here saying exclude. So it means include.
Yeah.
Yeah? Except. So that's why it should be an open bracket on both, because I actually want the -4 and I want the 4 there too. Yeah. How do I... Or G of F? Oh, good. Yes, very good question. So, let's do it the other way around now. So now that you got the idea of F of G, let's do G of F. All right? Let's have a look. I'm going to rub all of this off. We know the graph now. Let's do G of F. All right, here we go. G of F. Now, G of F is the same thing. G of F, if G of X was equal to X squared minus 16, and let's say F of X was equal to root of X, then G of F means substitute F of X into G of X. It means take this square root of X and replace where the X is. And what you can see here is if I replace it, this is what I'm going to get. I'm going to get G of F of X is equal to, instead of X squared, I now have root of X all squared minus 16. But what's the beauty? If you have a root of X and you square it, what happens there? Yeah, it becomes X. Yeah, they're just inverse of one another. They cancel out. And then what do you end up with? What's X minus 16? What's X minus 16? What kind of function do you have? Linear. So what's the domain and range for this one? Ah. Every number will work. There's no restrictions in any way. You can write the domain of this and whatever it is, it doesn't matter. Because you switch it around, this is the machine now. You have F here, and you have G here. This is root of X. And then whatever the domain is for F, the domain for F is currently 0 to infinity. Doesn't matter what it spits out, because the second one has no restrictions. A quadratic has no restriction. It doesn't matter. X squared minus 16, you can square any number you want. Doesn't matter what it is. Square it and the minus 16, you get a number. So it doesn't matter. There's no restriction on the second one. So I don't care what this spits out. Who cares what the range of F is? So the range of F is clearly 0 to infinity, but it doesn't matter. Because any number that spits out of this first machine is going to go in the second one. The second one's like, I'm free, man. I'm easy. It's like going on a date and it's like, hey, what do you want to eat? It's like, anywhere's good, man. I can eat anything. It's like, no, really, where do you want to go? It's like, look, you choose and I'll eat. There's no problems, okay? There's no restrictions there. So, it's the same thing. Okay. Previous function. Square root of X squared, yep. Yep. So, you would have to do a prediction there. So now we know the domain is only from -4 to 4, yeah? And then, yeah. So you know overall it's a root function. So obviously this is going to be like that on that side, because overall, if I go on the positive, root of 4, root of 10, root of whatever it is, it's going to be like a square root function. It might be a bit flatter, okay, because the numbers grow a bit slower. But then what about the negative side? It's because if I sub in a -4 squared minus 16, that's always going to be a positive. So it still follows a square root function. So, no, because when I say square root, let's say, pick a number over here, let's say square root of, I don't know, let's do, if 5 squared, does that, yeah, 5 works. 5 squared, which is 25, 25 minus 16 is 9, and then square root of 9, it's getting bigger, becomes 3. So it went from 0 to 3, so as you go down that way, it's going to follow like that. But that's what I mean. I didn't need to know that. I'm just looking at what's happening. But all you needed was the domain. Because if you got the domain, you can keep plotting to predict what the range should be. That's why they will give you something that you can do. It's not going to be something like maximum, minimums, and whatnot. It might have one where you have a maximum. That's where derivatives come in, where you find stationary points and you test. So that's essentially the skill. Okay. All right.
Do you know how you had the range? What was the range of?
Which one? This one?
Yeah, before.
You want to play, yeah?
Yep. That's the range of of F of G. Yeah, because we've got the domain, now we can, now it fits.
I didn't care if it's ugly or not. She let me draw the other, she let me touch it.
If you fix the domain,
So that
then
the
it will
range
always
fits.
this will always work. But it doesn't mean that that's the range.
Yeah.
Just because you make it fit doesn't mean that it is.
Because it's actually the range that has to be into the domain.
But sometimes it could be, you know how it was 0 to infinity? I could have had 1 to infinity.
Yeah.
I could have changed the domain instead of being -4 to negative infinity. I could have said -3 to infinity. That still would work. You know? And if I did that in my domain, then the range also changes. So not necessarily that if it fits, then that's the. All right, year 12s. Here we go. Let's. I think this is, what is this? Oh, that was my last property there.
Take a break. When the bar goes.
Yep, we can take a break. All right, what I want you to do is just one more. Okay, here we go. I want you to do this one now. Your turn. You've got the first function is x squared minus 1. Your second function is g of x, and it has a domain there, so x greater than or equal to 0. And you've got x element of r. I want you to state why g of f is not defined. And if it's not defined, then make a new domain to make it work. And what is that? So essentially what I just went through with you. Okay? Once you can do that example, that's an easy example of how to do exercise 1E. The last few questions 1E is what I want you to focus on, not the first half. First half is really straightforward and easy. You can do the worksheet if you want. It's the last part. What I'm doing with you right now is what you need to know of 1E. Okay, so if you're feeling a bit more like, oh, I get what he's trying to say, but I haven't yet got it, do it. Start doing those last few exercises. The last few questions are the ones where it really gets you to think about the domain, the range, how does it fit, what do I need to change to make it fit. And obviously this requires you to remember all your functions from year 11. So year 11, if you missed out on that gallery of functions, you know, square roots, hyperbolas, exponential, log, sine, cos, tan, all of that, that's when it affects this, okay? Because it's not the theory I'm saying that you don't understand, it's more that you don't know your functions. So you just gotta learn your functions. So go back to year 11 textbook, open it up, learn those properties again to memorize the graphs, or because you need that. Without that, no matter how good I am at teaching this, you're not gonna be able to follow, okay? Because the theory is straightforward, it's applying everything. Algebra, domain, range, sketch the graph. If you can't sketch quadratics, then all of this would have been gone already. Okay? So work with that. There we go. We've got these two. When the bell goes, give yourselves a 5-minute break, and then we'll come back, and then you work on your exercises on 1E. Remember, this weekend, I'll try to do exercise 1E and record it, and I'll put it up as a video. And if I don't do it, 2018, I would have done it already. Okay? But I want to do one for 2019, just an updated one. Okay?
What is A B?
To prove it, you just make a subset and then cross the line.
Yeah, you would cross the line if it doesn't equal, and you're right, that one doesn't equal.
State why G of F is not defined. What do you mean by that? A.
Which one? A?
Yeah.
So G of F, which means the function F is within G, I want you to tell me why it doesn't work. So I'm actually telling you that the machine doesn't work already. I'm already letting you know. Normally questions don't tell you that. Normally the question says, is G of F defined or not? So that defined just means, does this one work? Yeah. Does it spit out the final value? So if I put any number in, is it true that
So
I'll
you
get
basically
everything?
just find the domain and range of each and then see if they can work.
And then you use that property. Okay, but remember, it doesn't have to be G, it doesn't have to be F. It's the first function. So what's my first function in this case?
G.
No. F. It's G of F, so F goes into G. So the first one is F, and then the second one is G. So if you draw the boxes, it'll be F before G. Yeah. If it's the other way around, if it's F of G, then G goes into F. Then G becomes first, then F is second. This is power functions, and I'll get to that as well. But this is a x to the power 7 on 2. Yeah? I'll show you on the graph logically why this would work. Yeah, think about this, Alfie. If I gave you, so we're going to analyze sort of patterns, yeah? If you had x to the power of half, it looks like that. True? If I had x to the power of third, what do you think they'll look like? Oh, good. There's another one down. Why is that? Cubic or cube root. Cube root, you can have cube root of a negative number. You can't square a negative, but you can cube root a negative. So what ends out is that you actually get the second part too for cubics. Yeah? So any 1/3 to, let's say, 1/5 and 1/7 is going to follow that pattern that you can have negative numbers. True? That's why we've got odd and even functions there. Now, why is it that x to the power of half, if we know what this one looks like, then that means we also know what x to the power of quarter looks like. Why? What's the reasoning? Can anyone tell me why I would know what x to the power of quarter would look like? I'll give you another example. What if I gave you x squared and then I gave you x to the power 4? What's the difference between the two? Yeah, looks exactly the same. This one is quadratic, and then quartic will have a bit of a squarer jaw on the bottom. Then x to the power of 6 versus x to the power of 8, it has even more of a squarer jaw. It'll be squarer and squarer. And normally when I get to power function, I describe to you why that works, or at least I get you to think why that works. Okay? But we'll think about that. So the pattern is, if it's 2, 4, 6, 8, it's all going to look like a symmetrical look. Yeah? The reason why is x to the power 4 is the same thing as writing x squared and then square it again. True? So if I did an x squared graph, which looks like this, and I say square it again, I'm just taking these same values and I square it. 0 squared is still 0, 1 squared now is still 1, and then 2 squared, which was 4, now you square that again, that becomes 16. So they all still follow another massive, sorry, it's still a massive pattern. Okay, now, 1 on 2. Let's think about 1 on 2. If its square root looks like this, then what does 1 on 4 should look like? Less. Yeah, less. Because 1 on 4 is the same thing as saying x to the power of half to the power of half again. Because index laws is half times half is a quarter. True? Yeah, okay. Half times half is a quarter. But logically, what are you doing? This is your square root, and you say square root all the values again. So if you square root all these, it gets smaller. True? So I know what x to the power of 1/4 is. I know 1/6, 1/8, 1/10, and whatnot. But your question was 7 on 2. True? Now let's increase the values. And this is the special part. If it was x on 1 on 2, we know what that looks like. It looks like this. Then what if I increase the numerator to 2 on 2? What does that look like? Yeah, straight line. So 1 was curving this way, and this is like your equilibrium. So then what do you think x to the power 3 on 2 is going to look like? It's starting to curve towards your y-axis, because now this cubing or squaring, so this was squaring. So if you think about it, this is the same thing as saying x to the power of half, and you're squaring it. Yeah? This now is like saying x to the power of half, and you're cubing it. But each time you increase that numerator of the fraction, you're making it multiply itself more times. So that means at some point, the rate's going to be too fast for the x values. Yeah, and so because the y values skyrocket too fast compared to what the x is, it heads towards the y-axis. And that's why if I increase this to, let's say, 6 over 2 is the same thing as what graph? Yeah, and what's a cubic graph look like? Except we had a condition before that the negatives don't work, because we said x to the power of half is a condition, that it can't take negative numbers. So that's why it curves. That's why when you said x to the power of 7 on 2, what does it look like? Well, it's be thinner. But we heard that way. Yeah. But that's power functions. We'll get to that, and I'll talk more about that. It's like a whole session talking about. Yeah, because that is composite functions then. Right there, what we just did is composite. It's a function within a function. You have a x to the power of half within an x squared, or x squared within a function, and that's why, even though x to the power 6 on 2 is technically x cubed, but x cubed should have negative numbers. But if you type x to the power of half in brackets and then put a power 6 on the outside, this is different. This is not going to be all real values. The same shape as an x cubed, but it won't have the negative sign, because the range, the range of this does not fit. So the domain of this is already restricted, and therefore it gives you a different picture. Whereas if you flip it around, if you said x cubed, there is no domain restriction. And there's no, so that's why they're both different. So hence composite functions, the better you understand it, applies to power functions.
You know how we're supposed to restrict it? When we're writing the rule, you have to make the range 0 to infinity, right? But how do we write that as a rule?
A rule,
Yeah.
if you're writing it as, oh, where's my pen?
You just write the function and then say the range is 0 to infinity.
You would do domain of f star of g, or g of f, whatever it is, or you can say x element of.
But the domain doesn't change.
Doesn't it?
Because it's a quadratic. Because like, you want to look at it?
No, it will change. It has to change for it to work.
The range of x is -1 to infinity.
Yeah, so that's a problem. So that means g of f does not exist. Now we want them to exist.
Yeah, you want them to exist so that x minus that can't be -1 has to be 0.
Yes.
And so that would just be a cubic for the domain doesn't change.
Wait, what do you mean it's going to be a cubic?
So it's going to be quadratic. Like it's just going to be x squared.
Why is it just going to be a square? Where'd you get that from?
Because you can't have -1. Because if you have -1, then it's going to have x squared. But you want the 20 to be out.
No, the graph stays the same. You can't move the graph, but you can change the domain of the graph. So the domain right now is x element of r, so it can be any number. You want to change this. You don't want to change the equation itself. The equation is still x squared minus 1. It's imprinted there. But somewhere in this one, I don't want that -1 range. So another way
So you just find when y is -1, what x equals to 0.
Yep.
So then you just say all real numbers are positive.
That would still not work, because if I chose all positive numbers, let's say I chose half. So if I put half into this equation, half squared is a quarter. A quarter minus 1 is still a negative number, and you still can't square it. Now, your job, I would suggest, is to draw it. See, x squared minus 1, what does x squared minus 1 look
Do
like?
you get it when the x-intercepts?
Yes. Because remember, you're trying to get the range. So here we go. This is your graph. You were right that it was -1, which is down there. That's correct. You said that what you don't want is -1 to this. But I think you're visualizing this. You're visualizing -1 to infinity. What you need to realize, this is the range of f. So what you don't want is this region, which means any part of the graph here, that's where the bottom region is. We don't want that. We want 0 to infinity. Now, if part of the graph, which domain would have 0 to infinity for a range, as long as I choose numbers here, because that's when y is 0, and I choose the domain that way, the y values are always positive, which is what I want. So it has to be this x-intercept onwards, and this intercept onwards. So x squared minus 1, what's the x-intercept?
1 and -1.
Good, so this is -1 and 1, so I know that if I chose 1 onwards, so from 1 to infinity, and from -infinity to 1, or -1, sorry, this would work. Any of these numbers would work, but anywhere in between it's not going to work. So that's my new domain, which is pretty much what that is. Yeah. If you haven't had a chance to have a go, please have a go with this question. It's very much the same as the one I just did. The only difference is mine was -16 and yours was -1 now. Okay, same drill. Sketch the graph is my tip. The better you visualize in methods, the better it is to do the problems. Okay, if you can visualize it. And I know that's hard. So the whole time since year 8 to now, visualizing is hard. Understanding the graph, linear, quadratic, it's hard. That's the skill you want to take. Learn to picture what it looks like, because then you can analyze. You can't analyze without a picture. So draw them. Draw every graph that you can and try to visualize what the problem is. Okay?
So is the range for G negative, range and domain negative, 0 included to infinity?
Yep, for G.
Yeah, for the both domain and range.
Of what? G or G of F? Just G. The range is 0 to infinity, and yes, the domain is 0 to infinity as well. Yep. I'll give you another 4 minutes, and then I'll write up the solutions. Okay, cool. And then I want you to work on exercise 1E. That's your task, and tomorrow we'll go back to 1D. Sums and products, give you a bit of a break from all this theory. And then we'll come back on Monday with inverse functions, which is another tough topic.
So with A,
Yep.
isn't it that is defined because in the domain of G starts from 0, whereas the range of F starts at negative 1, so there's like that gap?
Yeah, all the...
Could you just take that gap and make it defined?
Which is what you want to do. But you remember, you can't just take a gap, because that gap you're talking about is the range. You can't just change a range. A range is like it depends on what you put into the machine. So remember, like, if you think of the machine like this, yeah? And you've got F first before G, true? Now, your range is -1 to infinity. You want to change this. You want this to equal to at least 0 to infinity. It could be 1 to infinity, it could be anything to infinity, but you know that it needs to be 0 to infinity. But you can't just say, yeah, just change here, because what comes out here depends on what you're going to put in. Yeah? So what you need to fix is this, and that's what the question's asking here. They're saying to find the restriction of F, which means find what you need to put in. What can't you put in to ensure you only get 0 to infinity? Yeah, and so now you got to look at the graph of F. So what's the graph of F? X squared minus 1, I'll draw it. That's what it looks like. Down 1, good.
And now we all the negative numbers.
Not just all the negative numbers. Remember, no. So you're confusing between the range and the domain.
The domain,
Yeah.
the whole side.
The whole, like this whole side? Okay, see, if I remove all of this, right, it's still a problem here, because if I chose a number here, so if X was this value, the coordinate on the graph ends up being a negative, and I don't want a negative. Remember, I don't want a negative number here. I said I want the smallest number to be a 0.
So then that side too.
So this side too.
Yeah.
So then what do I have?
Like you leave the first quadrant and just take off the third.
Oh, I see. Okay, but remember, you can't take off y values. You can only take restrictions. So you're saying only from here onwards. So you only want here. That is correct. Or where else? So you got another part too. Think about it. So you're right.
That side.
Yes. This is what you want, and that's what you want. Because you said you don't want any negative y values. So anywhere between here you don't want. So it's this whole region that you don't want. That's why the x-intercepts on this graph achieve a -1 and 1. If you chose any number from 1 onwards and any number from -1 downwards, it would work, because the y values are all positive. And that's what we want. We said that as long as you spit out y values that are positive, which is here, all the numbers, if I put a 1 into it, I'm going to get 0. And that's good. That's the minimum number that I can have. See, if I put 1 in, 1 squared minus 1 is 0. And that works. Square root of 0 is going to work. So as long as I choose any number greater than 1 or any number less than -1, it should be good. But I can't have any numbers in between. Yeah. So my new domain would have
No, R excluding.
That's it. And that will change the range. If you change the range, it works now. And
So
that's,
then for A, what would you say?
oh, first one is what you wrote in your book. So if you just wrote, because you knew the problem. What was the problem? You said that the range of G, oh sorry, range of F, needs to be a subset of the domain of G. That's what you said as a property. And then you found out that the range of F is actually -1 to infinity, and the domain of G was 0 to infinity. And then you would say it doesn't fit. So therefore, not defined. Because it doesn't work. That's why in the second question it says, all right, well, if the range doesn't fit, fix it. Make it work. And that's where you were saying, all right, as long as I choose these numbers, instead of it being R, see, R was the issue. We can't have R, but if you change that R to now X can be an element of any number up until -1, inclusive to 1, you should be good. Yeah. And that's essentially what they're trying to get you to do. Okay. All right, year 12s. Let's go through answers. Here we go. Number A. State why g of f is not defined. It is only defined, so you got to think of what does g of f mean. This just means g and substitute f of x in. If you want, draw the machine on the side. So here we go. We've got the machine. Got the machine. What does this mean? You're substituting f of x into g of x. So that means the first function should be an f because you're substituting, you're substituting the value of f. So f spits out a y value, which is f of x, and you're substituting into g. That's what g of f means, right? So now you know the first machine is f. What's the first machine? You've got an x squared minus 1. What's the second machine? You've got root of x. In order for it to be defined, we already said the first property over there is that the range of the first function needs to fit the domain of the second. So what's the range of the first function? I've got an x squared minus 1. Visualize it. Draw it. Okay, draw it. It helps you a lot. Draw the picture. So if I draw out f, this is my f function. X squared minus 1. Hopefully we're a bit faster with our quadratics at this point. It goes down by 1. Turning point is at -1. Find out your x-intercepts is -1 and 1. This is my graph. So if I ask you what the domain and range is, domain of f, range of f, domain of f is R, because they already told me. What's the range of f here? What's the range of f? -1 to infinity. Looking at the graph, smallest y value is -1. Goes from -1 to infinity. So that's my range. So remember, the first condition says, what's the range? What's the numbers it's going to spit out? Well, I know the numbers that it's going to spit out are all the y values here. That's -1 to infinity. That's my range of f. So what's the condition? I need this to fit whatever the condition, the domain condition of the second function is. So let's look at g. What's the domain of a square root function? So if you draw out the square root function, it looks like that. Then you're like, all right, well, what's the domain of g? Dom g and ran g. Domain of g is square root can't take any negative values. So you know it has to be 0 to infinity. Range, if you draw the picture and you look at it, well, it's also 0 to infinity. Now, according to the definition, for this machine to work, this thing says, I'm not taking negative numbers. This number says, oh, this machine says, I will spit out anything between -1 to infinity. Can you take them all? I was like, no, I can't. I can only take 0 to infinity. No negatives. There's a problem there already. There's a problem because this guy's saying, oh, well, I can do -1 to 0 as well. It's like, no, 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 no. I just want positive numbers and 0, but no negatives. That's a problem already. So where's -1 to infinity on the range? It's here. This is a problem. These are this whole dotted line or all of these lines here, that's what I don't want. Because any values I choose of x here, and I put it into the machine, I'm going to get these y values. And that's going to spit out into g, and I don't want that. That's what I don't want, okay? But to answer the first question, is it defined? No, it isn't, because the range of the first one, the y values are spitting out, doesn't fit the domain of g. If I highlight what doesn't fit, it's this. Whoops, yellow. The range of this does not fit the domain of g. That's the problem. I don't want that. Okay, so how do you write your answer for part A? This is how you do it. For part A, you would write g of f is defined when range of f is a subset of the domain of g. But you can't just write that. That's the first step. You don't get a mark for that yet. You get a mark for defining what the range of f is. So if you write underneath now and you say it's -1 to infinity, and the domain of g, which is 0 to infinity, and clearly there's a gap there. One takes negatives, -1 to 0, and one says, no, I only want 0 to infinity. It's not a subset. If you draw a number line to see it, there's a misgap there. It doesn't fit into it. So therefore, this is not a subset, and you do a backslash to it to say it's not a subset. Okay? Therefore, g of f is not defined. That is the proper way of answering a question like A. When it says state that is not defined. See, I've stated what my property was, property number 1. I've stated the range and domain. Okay, so it means I can read the domain and range. I know how to use set notations. Exercise 1A. 1B is the domain and range. 1E is the property of composite functions. And I've stated, I said, therefore, this is my answer. This is the proper answer. Okay? Second part of the question, now that you know it doesn't fit, it doesn't work. Second part of the question says, well, fix it then. If you know it's not going to work, make it work. And so here we go. We said, well, we can't have these negative values. That's a problem. I don't want anything, no range. I don't want any of this range. -1 infinity, I just don't want that. I want from 0 at minimum to infinity, because that's what they said. They said, I will only take 0 to infinity. From F's point of view, they're like, okay, I just somehow have to get rid of this. But the only way to get rid of a range is what you put in. Because whatever you put into this machine is what it's going to spit out. So tell them what you want to put in. What do you want to put in? Because initially you said, oh, I can take any number. But now that you're in partnership with another machine, you're like, no, I can't put any number in. There's a certain numbers that are going to give me negative values. And we know these X values are going to give you your negative numbers. I'm going to do in green. These numbers here, if I choose any of these X-axis values, it's going to spit out negative Y values. So that's what I don't want. So how do you fix it? Say just choose anything from 1 onwards. Because from here onwards should work, and then from here onwards should work because all the range values are positive. That's the hard thing to get your head around. Instead of looking at domains now, you're looking at the range. But in order to fix the range, you have to fix the domain. That's why it's counterintuitive. Okay? So the answer for the second part here, now that you can see you don't want this section, you can have any number except for that section, then your domain should be written as in part B, you should say the domain, which they wrote F star to represent the domain of G of F star is now equal to R excluding -1 to 1. Or you can do negative infinity to -1 inclusive, union 1 to infinity. Okay? But remember, in the very second session I taught you, what did I say? If it says define a restriction of F, or it says state a rule, or say something like that, what do you have to do? Write it in function notation. See that second part? A lot of students will miss that in a SAC or an exam. So that second part is your second mark there. Okay? Now, you would have only got 1 mark here. So the 1 mark is getting the correct domain. If you got that wrong, it's 0 out of 2. So your answer should be written in function notation because it has the domain and it has the function. So how do you write it properly? This is how it should be written. So whilst I know what the answer should be, this is what I would write. So I'd write G of F star, colon, you write the domain. So my domain is R \, -1 to 1, maps onto R, so that's the code domain, comma, and I don't have enough space here, but I'm gonna write here G of F of X, or of, no, sorry, not with the O. So G of F of X is equal to, what was it again? Square root of X squared minus 1. That's your proper way. Obviously all in a line. But that has a domain. It's in function notation. And you know you're doing G of F. And that's your composite function there. And that will work. This machine works because I told you exactly what numbers you can put in. So if you think about the boxes before, I've told you what numbers you can put in and don't put anything between -1 and 1. So the Y values will always work. That's that whole thing right now that we just did, that's the skill you want to master. And it's easy to start off with quadratics. You'll get different graphs as well. You got hyperbolas, rectangular hyperbolas, 1 on X, things to consider with square roots and hyperbolas. You got, what other restrictions can you have? You got, exponentials and whatnot, but to start off easy for you guys, it's all power functions. So you either got square root with hyperbola, or quadratic with hyperbola, or cubic with hyperbola. And that's it. Okay?
In that, you don't define the new restriction topic if you write it correctly in the function notation with the wrong domain. You see the mark? Like if you get the domain wrong, but you write it correctly in function notation.
Oh.
You get consequential marks if you get the first part wrong.
Depends where they put the marks. So every year, whoever's writing the exam or the SATs, it depends if they define that, yes, I want to know if they can write function notation. Then that's irregardless of whether it's correct.
Second mark writing function notation, yes, but
If it's not, then you won't. That's why in year 12 at the end of year, it's so important that you want to do everything just backup marks. You don't know where they're going to put the marks.
Yeah.
You don't know where they're going to say, yes, we'll take a mark here, or we don't.
so you like depends on
Yeah, and that's why you don't. That's why for everything you do, it's very pedantic. So like if you had an answer of 2 over 4, I don't know if they're going to penalise you or not. It's better just to write 1 over 2. It's like saying if you had 1 on root 3, it's better just to write root 3 on 3 rather than 1 on root 3, because I don't know when they'll say you must rationalise the denominator, when they don't.
So if the second mark just for the second mark transaction function, you get marks for the second mark right, your new domain is
Yeah. Or if maybe the second mark is just to say, did you get the composite function right? So let's say it wasn't even function notation. If you just got g of f is equal to root of x squared minus 1, they're like, yep, they got composite. And do they have a domain somewhere? Yes, they did. Great, got you 2 marks. We don't know. But that's why if you write it all correctly, function notation with the correct function, correct domain.
yeah. If you didn't know, you have to domain.
Exactly. And that, yeah. So then they would have to see how many would you be penalized for the 1 mistake. Then they would have to, talk at a meeting, and are you the only one in the state that did that?
And you just like see that if you say like goes A, B, and then you see
Exactly.
Your whole back.
Usually they don't design it such that that happens. They will design it such that you will lose the first and the second, and the third one's brand new. So you start fresh.
Yeah.
That's usually how it works. It will still be the same problem, but it starts fresh. That's for VCE exams. For SACs, you may have it going A, B, C, D, but for exams, then that's where our discussions come in. So we will come in and we'll say, do we give consequential or not? Is it too easy to give it consequential? Because then if you give it, some students might have guessed it. Like it might be a question where you can guess 1 or not 1, and it just moves on. Then you get students who suddenly get a spike of scores, or students who get a sudden drop of scores, and we have to make a call at that point. Yeah. All right. Thank you. That is the